Protons have a mass of 1 atomic mass unit, or 1 AMU, and neutrons have the same mass as well. And they are both found in the nucleus, in the center of the atom. And then the difference will be the charge of the proton is positive, while the charge of the neutron is neutral. So, proton positive, they both start with a P. Neutron neutral, they're almost the same word. Now, an electron is about 1/1800th of an AMU. You might also see 1/1837. Okay? It is going to be negatively charged. And we know our abbreviation sometimes for electron is E minus. So that minus, remember it's negative. And it is found outside of the nucleus, inside the electron cloud. So if we know the element's name, we can find its symbol easily. We can also find its atomic number, 92. And remember, the atomic number will be the same as the number of protons, and in a neutral atom it will also be the same as the number of electrons, 8. So these are also going to be 92. The mass number here at the end is the sum of the protons and neutrons, the sum of everything that's in the nucleus. So our protons are 92, our neutrons are 147, so we add those together to get 239. Since we know the symbol Cl, we can look it up or just know that it's going to be chlorine then. The atomic number we find is number 17, so protons and electrons are the same. The number of neutrons can be found because we know the sum of protons and neutrons, the mass number, so we subtract the number of protons and we're going to be left with 20 neutrons in the nucleus. For the last one here, if we have 27 protons, we also have 27 electrons, and the atomic number will be 27. So we look up number 27 on our periodic table. It's going to be cobalt, and our symbol for cobalt is CO. And our mass number again, protons plus neutrons, will give us 60. If we want to write the nuclide symbol for a certain isotope, we're going to first look up the symbol for strontium, and we get SR. And then we're going to have two numbers that we write over to the left, one on top of the other. The bottom number is the atomic number, so that's going to be 38 for strontium. And then whenever we find the mass number to write on top, we just take the number of neutrons and add the number of protons that we have, and then we end up with 90 for that mass number on top. So for number 7, we already have the nuclide symbol for phosphorus. The atomic number is 15, and the mass number, the sum of the protons and neutrons, is 32. So since 15 is the number of protons, 32 is the number of protons and neutrons. If we just want neutrons, we subtract them, and we're left with 17 neutrons. For number 8, if we're going to write the nuclide name, we first look at the symbol. K is potassium, so we just write out the entire name. Then we're going to have a hyphen or a dash, and we're going to look at the mass number on top. That gets written after the hyphen. Okay, characteristics of metals and their location on our periodic table. So this first section is all about metals. They are going to be malleable, which means that we can hammer them into a thin sheet. They are going to be ductile, which means we can stretch them out into a thin wire. They're going to be, or have luster, they're going to be shiny. And they're going to be good conductors of both heat and electricity. And we're going to find those to the left of our staircase. Except for which element? Hydrogen is a non-metal. So everything to the left of the staircase, including the bottom 2 rows, is metal, except for hydrogen. Okay, characteristics of nonmetals is basically the opposite of metals. They're going to be fragile. They're not going to be able to be manipulated very much before they break. Instead of being shiny, they're going to be dull or matte. Light will not reflect off of it as well. And it will be an insulator. It helps prevent the flow of heat and electricity. And we're going to find these to the right of our staircase. And, of course, hydrogen is also a nonmetal. Metalloids are the ones that border the staircase. They have a mixture of characteristics of our metals and nonmetals, and one of the key things there is that it's going to be a semiconductor. And because of this property, it allows us to control when it conducts and when it does not a little bit easier, so it's very good for technology, different computer things. So we're going to have these bordering the staircase, except for aluminum, which is metal. Okay, to find the number of electrons in these ions, first we have to know how many electrons they would have if they were neutral. Lithium, we look it up, its atomic number is 3. So that means that if it has a charge of +1, it has lost a negative electron. So it has a total of 2 now. Phosphorus is number 15 on the table. It would have 15 electrons neutrally. And so if it has a charge of 3-, that means it has gained 3 more electrons for a total of 18. Aluminum is number 13. It lost 3 for a total of 10. Iodine has 53. And then if it has a charge of -1, it gained 1 more. Unless we're looking at the transition metals, they're in the middle. These will gain or lose electrons until they have the same number as those noble gases in that last column. Okay, for naming our ions, remember if it's positively charged, that means it's metal, and we're going to just name it as is. Ba is barium, and Pb is lead. And then we might need a Roman numeral after it. It all depends on if we look at the periodic table and if we know the charge. Barium, we look it up, it's 2+, so we do not write the charge in Roman numerals. We just tack on the word ion. Lead, when we look it up, it's in the question mark column, which means that we do have to identify that this has a charge of 4. So we're going to put IV for 4 in Roman numerals before we put the word ion. If they're negatively charged like these two, we do not use Roman numerals, and we will change the ending of it to IDE. So nitrogen becomes nitride ion, and then Se becomes selenide instead of selenium.